Okay, guys, we're on page 18. We have one more section to go over, and then we can start reviewing. We'll start reviewing on Monday.
Oh, yeah. I'll say, like, please. It's technically Friday.
What are we fighting?
Should we say?
Okay, page 18. We did sum and difference identities. Today we're doing double angle identities. So there's a way that we can expand out sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So we're going to be working with these in addition to the previous identities that we've learned. And again, you can always reference the other identities from the back of your calendar or from the back of this packet. I also included it as the last page in your packet. Okay, so let me go through these identities here. Sine of 2 theta can be expanded out into 2 sine theta cosine theta. Cosine of 2 theta, there's 3 variations, but really we're just using the Pythagorean identity to make substitutions. So but these are listed, so it's easy access for whichever form is going to help us the most. And then tangent of 2 theta has its own expansion. So we're basically taking a double angle and splitting it up into something involving just theta. So example 1, it says use double angle to find the exact value. So sine of 15 is not an angle that we recognize from the unit circle, but if we think of it as working it from the right side to the left side, because it matches, right? We know that 2 sine theta cosine theta equals sine of 2 theta. So if we match up all the parts here, then sine 2 theta would just be sine of 2 times what? What's the theta? 15. So all we're left with is sine of 2 times 15. And 2 times 15 is 30. So now this becomes something that becomes more recognizable, right? Now that we've converted it using a double angle identity, we now can transform this into a value that we know. In a circle, sine of 30 is going to be root 3 over 2. Right? All right, sine of 30. Oops. My bad. Sine of 30 is going to be 1/2. Okay, so we're going to practice using double angle identities for these next 2 problems here. Everybody okay here with this problem? All right, so double angle identity, we have cosecant of 2x equals 1/2 secant cosecant. So we're always doing this. We're always working just from the left side and trying to create different versions until we get to the right side. So we don't have an identity for cosecant of 2x, but what's something that's related? Sine, right? We know that I can transform this into sine by just making it the reciprocal, right? So we know that cosecant is the same thing as sine. Sorry, reciprocal of cosecant is sine. So if I put sine in the denominator, then I've created an equivalent expression, but now I can use an identity to represent this. Right. So I'm just going to just leave that expansion in the denominator. Let me zoom in a bit. Okay, everybody okay here? This is just using the double angle identity at the top of the page. All right, are we any closer to where we want to be? Okay. What if we think of this as 3 fractions being multiplied together? So I can think of this as 1/2 times 1 over sine of x times 1 over cosine of x. One half, well, that's showing up there. What's 1 over sine? Cosecant. And what's 1 over cosine? So that leads us to what we want, where our destination is. All right, number 2, cosine of A minus sine of A. This is one of those problems where we have to kind of create something out of nothing. And that something out of nothing is maybe I can create a situation where like a cosine squared or sine squared will appear. But I want to do it in a way that will allow for some clean representations. So because there's 2 terms here, we always like to target conjugates. So because we know that conjugates will allow for difference of squares and it's going to come out cleanly. So we're going to multiply the numerator and denominator by the conjugate term because we know we're hoping that an identity will show up. But whatever I do to the top, I need to maintain balance and do to the bottom. And the right side is also kind of giving me that indication, right? That I want a cosine of A plus cosine of A in the bottom. So if I want to do that, then I can create a situation where I have the same numerator. Okay, so already I'm getting closer to my goal because I already have the denominator matching up. Just have to figure out what to do with the numerator. Okay, so let's multiply everything through. What happens here? Yeah, middle terms drop out. Okay, cosine squared minus sine squared. Do you see something that we can do with that? So, yeah, you see that? We're trying to target cosine of 2a, and this goes back to one of the new identities that we're just learning here. So it actually is going to match with one of our options, right? Cosine squared minus sine squared. So this is one of the new ones that we're learning here. So we know that cosine squared minus sine squared. We're trying to make it look like cosine of 2a, and we got that perfect match. Right, that's the identity that we can use there. Okay, so we have our end result. Any questions here? Okay, so for the rest of this page and next page, it's just going to be an assortment of rules that we've practiced with, identities that we've used. So Let's go to number 3. All right, number 3. Okay, I want to get this down to sine of 2x. There's probably going to be an identity that I can use. But first things first, what do you think we should do here? Yeah, let's just expand everything out, right? Let's expand everything out. So make sure that you FOIL out the terms, that you don't just distribute the exponent through, that you write the parentheses out twice and spend the time to expand. Let's do that. Okay, so distribute, get rid of all the parentheses, and let's see what happens. All right, do you see any like terms that we can do here? Yep. All right. Anything else? I see something else here. I see sine squared plus cosine squared. Yeah, I find that a little faster, although there may be other ways that you can do to get that cleaned up. I'm just going to see that as 1, and then 1 minus 1 is 0, right? So we know that all that is just going to go away. So this, all right, they all end up canceling each other out. So, yeah, go ahead.
The combined middle term can return to sine 2x.
Good. All right, that is our double angle identity. 2 sine theta cosine theta becomes sine of 2 theta. All right, questions with 3? Okay, number 4. Number 4, cosine of x minus 1. There's not a whole lot that we can do. But if we look at the right side, we know we want the right side to have that denominator. So it's kind of like creating something out of nothing here. We can multiply the numerator and denominator by this denominator. And also that's a good match because it looks like there could be a conjugate relationship there. So again, I'm making something out of nothing, but then I'm using the right side to kind of help me decide what could happen to make me get closer to my goal. So I'm going to multiply numerator and denominator by 2 cosine of x plus 1 in the hopes that I can get a denominator to match, but then I can also hopefully get the numerator to clean up in a way that will match my end result. So I'm going to FOIL the numerator out and leave the denominator alone. But as I FOIL, I'm going to leave the 2 alone for now. I'm just going to multiply. Here, I'll show this. I'll multiply the parentheses through. So the parentheses will give me cosine squared x minus 1. I know that the middle terms will drop out. I'm sorry, that should be a minus 1. Cosine squared x minus 1. Okay, I'm actually not going to try to cancel the 2 out because I think this is going to be helpful to eventually convert it into a double angle that I want to use. So I'm going to distribute that coefficient through the numerator. Okay, so I want you to observe what we're trying to do here. We have this, and we're trying to get to that cosine of 2x. Okay, so if you look at the top of the page, the identity that looks the closest, because there's 3 to choose from, right? The one that looks closest to maybe the one that we can target is this one. Cosine of 2x equals 2 cosine squared x minus 1. So do you see something like that where I can substitute? Yeah, what if I split this up into minus 1, minus 1? Just so I can get a clean substitution that I'm looking for here. Okay, so we're kind of playing around with the form to kind of make it fit into this right side that we're targeting. So now that I kind of split that, because I haven't changed anything, I just made it a little bit easier to recognize. Do you see a replacement for cosine of 2x? Yeah. All right, I can replace that piece with cosine of 2x. And I think that will lead us to what we're trying to achieve. Okay, any questions there? Okay, back page, 19. Number 5, are we good here on this page? Okay.
Question.
Yes.
How'd you get the 2 cosine x plus 1 for like the first step that you did?
Oh, how did I get here?
Yes.
So the way I got there was because I knew I had to create something out of nothing. Because, let me go back to that page. Because I don't have anything where an identity can be used, right? Cosine of x minus 1 is such a simplified expression. There's nothing I can do, so I got to create something out of nothing here. So what do? I know I got to involve conjugate, but I'm also looking at the right side to help give me some hints there. I know my denominator wants a 2 cosine x plus 1, and that is matching nicely with what I want in the numerator as well, so that kind of helped guided my efforts there.
All right.
And then that conjugate relationship in the numerator worked out nicely. It created an identity that we can target. Yes.
Anyway, can you explain how you did the second to last part to the answer?
Yeah. So you're good with that 2 cosine squared x minus 2?
Yes.
But we're trying to target this property, 2 cosine squared x minus 1. So I'm going to just split them up. I'm going to make -2 into -1 minus 1. And if I split it up, I can make a substitution for a portion of it. You see that 2 cosine squared x minus 1?
Yeah.
I can replace that with cosine of 2x.
Oh,
And then once I remove that, then I'm able to, so I keep looking at the right side to see, okay, what can I do to make it look like the right side? So every decision I make, I'm always looking to see, am I getting closer? And if not, then I'll try making adjustments to get this puzzle to fit. Okay, any questions here? All right, let's look at number 5, page 19. All right, secant of 2x. We don't recognize secant of 2x, but what's more recognizable? Or what can we turn that into to make it recognizable? 1 over cosine of 2x, okay? Okay, what's the identity that we can choose that looks most like? Okay, so are we getting any closer to the answer?
Yes.
Yes. Are we there yet? I was thinking that too. I was like, how do I get that numerator to show up? Yeah, that's what I was thinking too. I was struggling with this. I was like, how do I get that numerator? Well, look at the numerator. Does that ring a bell? Yeah, I didn't see it. I was like, how do I get this to show up? That's an identity, right? Cosine squared plus sine squared equals 1. So we're just putting it back into that form. So I was already staring at the answer. I didn't know why I was struggling with this. You guys see that? Right, because cosine squared plus sine squared equals 1. So we're just going to replace that 1 with cosine squared plus sine squared. I don't have to do any more work. Okay, number 6, we're going to have to revisit a double angle identity, sine of 3x. Okay, we don't have a rule for sine of 3x, but we can split sine of 3x into something that we can work with. We have single angle and double angle, so let's think in terms of x plus 2x. All right, we don't have sine of 3x, but we have sine of x, we have sine of 2x. And now if you look, this matches with some identity that we learned yesterday. So let me write that rule above. Sine of a plus b can be expanded into sine of a cosine of b plus cosine of a sine of b. So we're able to represent 3x as x plus 2x, and now that matches our sum identity, and we're going to just spell everything out. And then we're going to have a much easier time kind of making progress from there. Okay. So A is x, and B is 2x. So I'm just going to follow the formula. So we're hoping that we can eventually convert this to be the right side. What's something that we can begin to target to change? Yeah, let's get all the double angles to be converted. Now we have 3 different versions of cosine of 2x. Which one would you want to choose? Say it again? Okay, why that one? Yeah, in terms of sine, right? I look at the right side, all I want is sine, so that will get me the, that'll be the quickest path to my answer. So cosine of 2x, look on the previous page. 1 minus. So I'm just making the substitution there. Okay, sine of 2x, I have no choice. There's only one of them, so it's going to be 2 sine x cosine x. Okay, I'll distribute. I know there's still cosines in the way, but I think once I multiply these cosines together, I think cosine squared can then be adjusted later on. Okay, so one final thing to change, right? That cosine squared is kind of sticking out. We want that to go away. What can I replace cosine squared with? Yeah, we have an identity for that, right? One of the first ones we learned. Okay, distribute the 2 sine x through. And we should be getting near to our results, right? Combine like terms, that becomes 3 sine. Combine like terms, we get a negative 4 sine cubed. Yes. Okay. Number 7, same idea. We're going to think of sine of 3x as cosine of x plus 2x. And I'll write the rule there as well. Is everybody okay with 6? Okay, here's number 7. All right, follow the rule above, expand everything out. And then piece by piece, you're going to convert all of your remaining double angles to be hopefully closest to cosine, or eventually in terms of cosine. A is x, B is 2x. All right, what would you want to replace cosine of 2x with?
2 cosine squared.
Yeah, that's probably the one that's going to get closest to our right side the quickest, right? There's only one option for sine 2x, so. We still have sines in the way, but we are expecting that sine squared to show up, and we can replace sine squared later on. Okay, one more piece to replace, and that's that sine squared. I'm going to put the cosine x first, and then I can just distribute through. Okay, almost there. Combine like terms. Yes. Okay, any questions with 7? Okay, taking a look at number 8, we have a new identity that we haven't seen yet. That's tangent of 2 theta. Okay, does anybody still need this? No, okay, all right, so here is 8. You see that tangent of 2 theta? I'm gonna just go ahead and, I gotta involve that identity somehow, so I'm gonna put that to the side here. So really, our goal is to make it look like this. Because once it looks like that, we can make it tan 2 theta. So we know tangent 2 theta is 2 tangent theta over 1 minus tangent squared. Everything's in terms of tangent. That's something that I see here. So what could we do to start off our... Say it again?
Common factor tangent.
Common factor tangent.
Multiply the fraction of tangent over tangent.
Yeah, I was thinking about that. But that cotangent is still potentially going to present an issue. I was thinking maybe that could work. I was thinking just converting everything to be in terms of tangent. So I'm going to go that path. but I think there could be multiple ways to get to that. Also, there's two terms in the denominator. I just didn't know what I could really accomplish with that. So I just want to get all the tangents to show up. So cotangent we know is the reciprocal. This time I don't want to choose cosine over sine. I want to choose 1 over tangent just to make it begin looking like what I'm trying to target. So my entire focus is just in the denominator. I see there's a chance for me to create a common denominator, merge those into one fraction. So I'm not going to do anything with the 2, just with the denominator. What's my common denominator here? Tangent theta. Okay. We balance each fraction. No adjustments needed here. How about the second denominator? Needs another tangent. Tangent times tangent is tangent squared. So this is what I have once I merged my fractions together. Okay, so now I have at least have a fraction over a fraction now. I can move that denominator up by multiplying by the reciprocal. So let's see where that leads us. Okay, are we close? Yeah, we're almost there. We're basically there. So this matches perfectly with our identity, so we can now call this tangent 2 theta, and there's our end. Okay, questions with 8. Okay, the next few will look like review, because 9 through 11, we're just doing a bunch of factoring, trinomial factoring. So I find it, I think for many of you, potentially it's visually easier to just make it into a factoring problem with x's, do the factoring there, and then bring in the cosine or sine or tangent. Okay, does anybody still need number 8? Okay, here's number 9. So I'm looking at the parentheses here. I got cosine to the 4th, cosine squared, and 1. That looks like a chance for me to go through factoring. So I'm going to rearrange that. Make my highest exponent come first. Standard form. Okay, so hopefully we can recognize this as a factoring problem. Let's create an easier version of this problem, and then we can bring in back the cosine. So I'm thinking, can I factor x to the 4th minus 2x squared plus 1? If I can factor that, then I can bring in the cosine later. Okay, so what does this factor out to be? Mm-hmm. Yeah, multiplies to be 1, adds it to be -2. Those numbers will be -1 and -1. Okay, but the x is just a placeholder for us, right? We know we want to bring back cosine. Okay, do we have an identity for, do we have a replacement for cosine squared minus 1? Okay, close. We gotta be careful here. What's cosine squared minus 1? Negative sine squared, right? negative sine squared. Now, in the end, it's not going to, if you made a mistake, it wouldn't make a difference in the end, but for this problem, because there's two negatives here, but I want to make sure that we don't just forget that there could be, yeah, so just be careful with our signs here. Okay, so cosine squared x minus 1 is a negative sine squared. And duplicate here, so also a negative sine squared. Okay, so the two negatives, they do cancel out, but add up all the exponents. 1 plus 2 plus 2 is 5, so sine to the fifth. Number 10, same idea. Recognize that as a factoring problem. We just deal with a leading coefficient here. So I like to factor with that, pushing that coefficient to the back. Feels like an easier problem, just don't want to forget about that 4 at the end. Right, 4 times 3 is 12. So if you think about this, it's an easier problem here, right? Multiplies to be negative 12, adds it to be 1. Plus 4 and minus 3. Okay, so just be careful here. This is an adjusted expression. We still had to bring in that 4, involve that 4 at the end. 4 for 4 reduces to be 1, but 3/4 we need to pull that 4 out in front there. Okay, let's bring the tangent back since ultimately it's in terms of tangent. Okay, are we getting closer? Yeah, we're almost there, right? Just to make a slight adjustment. What can we do here? Yeah, got an identity there, right? Okay, so we're at the end now. Okay, number 11 is also factoring. Take a look at that, see if you can decide what to do, and I'll go over it. Okay, is anybody still working on number 10? No? That's good? Okay. So let's look at 11. Secant 4x minus tangent 4x, what does that look like to you? Yeah, factoring, right? Difference of squares. We know a to the 4th minus b to the 4th. A squared minus b squared. A squared plus b squared. Okay. Okay, look at what we have and look at where we want to get to. Any ideas? Okay, how about this? everything you see is in terms of what? Tangent. So let's just get rid of what? Can we represent secant squared in terms of tangent? Okay. Got an identity, right? We know that 1 plus tangent squared equals secant squared, so we'll just pick those things out and put in our tangents. I'm sorry?
Secant squared minus tangent squared also equals 1.
Oh, that's right. So yes, you're right. So we can just jump to that conclusion, right? Okay, so yeah, 1 plus tangent squared equals secant squared. Secant squared minus tangent squared equals 1. So yeah, that speeds things up. Here, though, I'm going to make that substitution. Secant squared is 1 plus tangent squared. Okay, so all this is 1, and then this can combine, and now I have my match. Okay, thanks. Okay. Questions? Okay, one last one, number 12. I'm starting off with cotangent of alpha over cosecant alpha minus 1. Maybe you're thinking convert everything to in terms of sine and cosine, but I'm looking at the right side. The right side is in terms of the trig functions that I already have. So it's just that I don't have them in the right spots. So this is one of those situations where, well, if I can get an identity to show up, maybe I can make some adjustments. So what can I do to create an identity? What could I multiply by? So I'm thinking, what if I multiply top and bottom by cotangent? Because I already need a cotangent. And if I have cotangents up top, that will give me cotangent squared. Right, we know cotangent squared is going to produce an identity that we can use, just as a reminder. Right, oops. All right, so let me multiply across and see what happens. Cotangent squared can be represented in terms of cosecant, and hopefully that will take care of this piece that we hopefully want to move. So cotangent squared is the same thing as cosecant squared minus 1. Okay, we're getting close, but we don't want to be careless and start canceling out here. What can we do to make this a better match? Factor, difference of squares, right? We don't want to be canceling this out. The addition subtraction sign is making it incorrect to do that. Okay. Okay, are we there? Cosecant alpha plus 1 over cotangent of alpha. Questions? Okay, leave your packet out. Let me check 18 and 19. Yeah. Give me a moment. I'll do it.
Didn't see what I said. I said that earlier. I think it was during lunch.
Oh, yeah. Are the videos on the website?
I'll put the key on the website too. Which number? Number 7.
Well, I mean, there's only 4 minutes left. What's your next class? It's the art. Oh, shoot, you're gonna go all the way down and all the way back home? Or you can walk to get my stuff then. Yeah.
It'd be fun to take your day off.
He said.